Hello, my name is Choi, a second-year PhD student at National University of Singapore. I'm working on distributed systems research with my supervisor, Jiarin Lee, assistant professor in NUS. Traditionally, distributed systems were designed on the assumption of asynchronous network, where messages can get reordered or even dropped arbitrarily, which makes things much more complicated. In particular, a standard approach for state machine replication, Paxos, suffers from significant performance overheads due to multiple rounds of communications among replicas. Taking advantage of advanced computation capability of reconfigurable switches, a recent system design called NoPaxos designates a single switch in the network as the sequencer. As a request has been forwarded to the sequencer, it writes the sequence number into the packet header and forward. Using these sequence numbers, replicas establish a consistent order of messages. Moreover, in case a message is dropped on the way to one of the replicas, it can detect not only that it is missing a message, but also the sequence number of it. Using this in-network ordering protocol, NoPaxos achieves single round-trip processing of client requests with no coordination among replicas in normal cases. Then, why don't we employ this network ordering model on practical systems? Unfortunately, several limitations remain due to the fundamental requirement of designating a single sequencer. First, limited scalability in terms of the sequencer processing capacity. Second, long sequencer failover time. Third, network load imbalance. In this work, we are designing a new system called Hydra, allowing messages to be sequenced by multiple independent sequencers. Obviously, the first challenge here is how to order the messages from different sequencers to be consistent across all replicas. Our core idea for that is to use loosely synchronized local timestamps of sequencers and order the messages based on the timestamps. On top of that, this idea of in-network ordering with multiple sequencers raises many interesting questions to be explored. Hopefully, we will propose the complete version of Hydra soon with all three properties of scalability, sequencer fault tolerance, and network load balance. Thanks for your attention.